did, yeah, there were two people, it was you and somebody else. Oh, Quinn.
Oh, no, me and Bryson got 106 also.
Oh, you and Bryson got 106.
There you go.
Okay, 5, 4, 3, 2. All right, now kids, today we have lesson 12-3. Never have had to call him. Okay, so lesson 12-3. Let's talk about the buzzword first. All right, in the buzzword, does anybody remember how to graph an absolute value?
Very carefully.
Plug in the opposite very carefully. All right, now there is a V shape, right? And do you remember we did a whole chapter on shifting graphs? And if you have a -10 on the inside, is it right, left, or up, down? Which one is it?
Right, left.
Anything on the inside is horizontal, right? But anything on the inside is opposite of what you would think. So it shifts the V shape to the
Right.
right.
Jordan, you
Why
said
is it
left.
a
Okay. The one who said that.
Okay? Because -10 becomes actually +10. Right? And there it is. Now, do you remember talking about phase changes way back in the first semester? There was one type of function where we talked about phase changes. Do you remember the name of that type of function?
But this is a +10 opportunity right here.
What was the question again?
I'll give you a hint about the type of function where you talk about piecewise.
Integral? No.
Phase change.
Matrix piecewise. Is that how it is?
You said it.
Wait.
You said
What was that,
piecewise.
Jill?
You said piecewise.
I said
You
She
said
said it way earlier.
And Jill said it like
Jill
10
said it like-
minutes
But you already said it,
ago.
okay, good. I thought there was a, I already said it, I'm giving things away. Okay, Jill and Thomas, you are correct, you get +10.
Another one. He said piece was like, what else can there be?
She gets a +20. Easier. I'm losing my mind with painkillers. Okay, anyways, all right.
Shouldn't say that on camera.
Oh, I mean, Dr. Mooney.
Why are you on painkillers?
Well, I got all these back problems anyway. Oh, gosh. Okay, so, what we have here is the fancy bracket. Remember the curly bracket? And you write like an equation, you have like x is greater than or equal to 4, x is less than 4, remember these? Okay, piecewise functions. So, in a piecewise function, you're supposed to name the phase change. Now, if I give you a piecewise function, gee, I wonder what the phase change is. 4. Where does it change over from being one curve to a different curve? 4. Okay, it's pretty much given to you, right? And wouldn't that be like I have a parabola and then all of a sudden it became a line? Kind of like those, okay? We're going to bring back some piecewise action actually in 12-6, the very last section. Yes, piecewise action.
This is the last.
Very last section of this chapter. Okay, now, so that's piecewise. Now, if you look up here, I asked for the phase change in the buzzword. But that's not a piecewise function. Where's the curly bracket? It's just an absolute value. It's just a regular function. But I have a surprise for you today. An absolute value is two different functions fused together. So it's the only kind of piecewise function where you don't see the curly bracket, but it is piecewise. As a matter of fact, it is a line that has a what?
Negative slope.
Negative slope fused together with a line that has a positive slope. So that's a piecewise function. How about that? Interesting. So it's actually two functions, not one function. All right? Sometimes you can have like 3 or 4 functions make an absolute value. You never know. So, can somebody tell us what the phase change is here? X equals 10. Did anybody put that down before we discussed it, by the way? Just put down 10? Just for thinking that? Anybody think of it? Okay. Good instincts. Isn't 10 where it changes from the one line to the other line? So that's its phase change. It's where you change over to something else. Okay? All right, so there it is. So, phase changes. Now, let's start with the first one here in the notes. And this is a very strange graph. Very strange graph. All right, so we've got absolute value of x minus 3 plus absolute value of x plus 4 minus 2. Okay, now, before we graph it, let's kind of test the waters here. I'm going to kind of get an idea as to what this looks like. Okay, it's an absolute value. It should be some kind of V shape, I guess, right? Okay, absolute value. So, let's test it out a little bit here. All right, let's start with 0. If you take 0 and you plug it in, okay, do that part in your head. 0 minus 3, absolute value of that. 3. Okay, 0 plus 4, absolute value of that. 4. What does that give us? Okay. Therefore, whatever this graph looks like, it must pass through the coordinate
0,
0, 5. Very good. Okay? Because we are plugging in numbers into the original equation, aren't we? Which only gives us y coordinates, right? So these are coordinates. Okay? Let's try 1. What's 1 minus 3 absolute value of that? 2. 1 plus 4 absolute value? 5. That was negative 5. Yeah, 5 again. Maybe that's like a mirror image of the V shape. They're like at the same height, and they're mirrored. Because if you look at a V shape, it would be the same height on both sides. Okay, got the same thing. All right, let's try 2. We'll definitely get something different here, right?
No.
Okay, we should. We'd have to, wouldn't we? Not necessarily. This is a crazy graph we've never seen before. Take 2, plug it in. Absolute value of 2 minus 3. 1. Absolute value of 2 plus 4. 6. Minus 2 is? 5. I'll be darned. What in the world's going on here? You're getting all 5s. There's only one kind of graph that stays at the same y coordinate forever. Isn't that a horizontal line? Yeah. There's no way that could be a horizontal line though, because the only way to get a horizontal line is one equation.
I mean, y equals number.
Y equals number. And that's not y equals number. So something else is going on here. But something's flatlining in this problem, I'll tell you that. Or zigzagging through it, I guess. I guess like in a sine graph, you could actually zigzag through those points. Okay, well, let's investigate further. Let's list the phase changes. What do you think would be the 2 phase changes of this graph? Looks like it would be, oh, by the way, I should have mentioned this over here. When we got the 10, how can you just look at that and spot that 10 is the phase change in the bus bars?
The opposite.
Basically, it's what makes the absolute value neutral, right? Not positive, not negative, but neutral. What makes this absolute value right here neutral? 3 and negative 4. Those are going to be your phase changes, otherwise known as the corners of your graph. Because isn't the phase change of the V shape the actual corner of it, the vertex? So these are your corners right here. Okay? Now, what in the world's going on? This is a crazy graph. So let's do this. Let's go to our nemesis, our buddy, the calculator, and let's see if we can graph this thing. See what it looks like.
Where do we go for absolute value?
Okay, I'm going to tell you. All right? All right. Now, it would take you a long time to plug in points by hand and try to graph this out. So let's everybody go to y equals. And you're going to write this down on your notes to remember what we did. We went to y equals. Okay? Now, first thing we have to enter is absolute value bar. There's not an absolute value bar on here. Okay? Well. If you want to find where something is on the calculator,
What the heck?
hit
Nah.
the math button.
Yeah.
If you go to the math button, you'll have all the goodies in there, okay?
Right.
Like cubes, cube roots, all kinds of stuff. Okay, now, hold on, just jump open the presents. All right, so everybody go and write this down in your notes so you won't forget it later on. Math, and arrow over to num for number. And look what we have here. ABS is absolute value, okay? So you will choose ABS. And that will give you an ABS, it won't give you a bar, but that's what it means, right? Okay, now we will type in what? Actually, let's just do this. X minus 3, close parentheses because that's the other bar, plus, go back to ABS, X plus 4, minus 2, and just like that. Okay? X minus 3, close the bar, plus. Let's see if this little trick works right here. Okay, X plus 4 minus 2. And let's just keep it on the factory default, which is negative 10 to 10 on the window. That's fine. And if it's not there right now, actually it should be from your homework, but if it's not there, go ahead and set it. Negative 10 to 10, negative 10 to 10 in the window. And when you graph it, I'll be darned. That's a graph you've never seen before. How about them animals? Kind of a V shape, and you get that flat. Oh, you know what? That flat line is the thing we were finding right here. We were plugging numbers right there.
And it was negative 4 to 3.
Okay, and the corners are negative 4 and 3 because those are your phase changes. So that's -4, and that's 3.
It's like a piece puzzle with three equations.
Yeah, right, so it's 3 pieced together, basically. So you could write it as a curly bracket in 3 different functions, or you could just write it like this. Interesting. Okay, so there it is. Now let's see, where's the axis? The axis is right there. Okay, and go ahead and draw that on your notes here and label it -4 and 3, because those are important, of course. Okay, and there's your shape. Strange one.
Yeah, it's on. Things up.
Unfortunately, it will not help to go to the alpha mode and type in A and B and S. You can't type in those letters, it won't recognize it. So you have to do the A, the S, no choice. All right, now, so for number 3, where is this increasing? Now that you're looking at the picture, and if you've labeled your corners, it's very easy. Where is this function increasing?
3 is less than 2.
And it's interval, so you can say 3 to infinity. Now, you can't ever get to infinity, can you? That's parentheses. What about the 3 window? Kind of in that middle territory, but you actually don't want to count it. You would do parentheses 3 to infinity. Okay. Right at the corners are kind of in between the 2 worlds. It's kind of like when you throw the ball up in the air and it goes up and it stops for that one moment and it comes down. Okay. So I wouldn't include 3 as increasing. I would just say 3 to infinity. And it would be decreasing where? Infinity to -4. So you can label corners. It's easy, right? Dead blasted bell. Crosses me every day. All right. And then where is it constant? What does that mean? Oh, yeah, where it's level, it's constant, isn't it? It's not increasing, not decreasing. So that would be from -4 to 3. And as far as parentheses and brackets go, you would actually even want to do parentheses here.
But it's a point.
Because it's that weird corner that's not really in either world. It's kind of a transition right there. Okay? I think you might possibly throw it into the constant part, but you don't. Okay. All right, there you go. So that's pretty easy, right? Just grab it and do it. Now remember, Mr. Wade has taken the final exam already. All right, the little scouting report for you, and sure enough, they have one of these on there, just like that. You can graph it and then do the multiple choice. You got it. I think it was just like only increasing or only decreasing. I think it was. It's easy.
So is our final exam going to be the EOC, or are you going to write your own?
No, and we have to give the like the CCE is what it's called.
Oh, that's what it is.
Yeah, we have to give the county's name.
But that's going to count as your exam, and you're not going to write your own?
Right. I wrote my own until last year when they came in and they said everybody has to take the same exam now. So, but I have taken that exam myself. I've seen it. That's on there. All the stuff we talked about this year, the easy stuff's on there. You'll have no trouble with it at all. No trouble.
All right, did yours?
No, I can't take any pictures of it. Sure you can. I'm just gonna keep erasing here.